Alright, so this is going to be a short video on the sine and cosine functions, which are two of the few trig functions that you know at this point, I'm sure. So they are, if we have a right triangle, which I'll draw right here, and that's our right angle, our 90-degree angle, and that's our angle theta, right? We could call this side opposite, this side adjacent, and this side the hypotenuse for the longest side of the triangle, right? And then the sine of theta is defined as the ratio of the opposite side over the hypotenuse. So the ratio of this side over this side, right? And then the cosine of theta, you know, is the ratio of the adjacent side over the hypotenuse. And you're really just told to memorize that. You're not told much more about really how they're related, or at least I wasn't. So learning this really helped me better understand the sine and cosine functions. So if we're going to draw them, if we're going to draw a graph of sine of theta, let's say, we would more than likely start by writing out our unit circle, which I'll put right over here. Why not? So that's going to be our unit circle. And it's a circle. That's not a very good circle. Pretend that's a good circle. And it's going to be a unit circle, right? And our unit circle has a radius of 1. So this is going to be 1. This is going to be 1. This is going to be negative 1. And this is going to be negative 1, right? And so if we're going to label these points, which we should do, because this is going to be when our angle theta is 0, and our angle is going to be the angle that the line is going to make with the positive x-axis. So if we're talking about this line right here, this line makes an angle of 0 with the positive x-axis. So, and this point right here is 0. I'm sorry, is 1, 0, right? X value 1, y value 0. Up here, if we're going to write the value for this point, 0, 1. Here is negative 1, 0. And here is 0, negative 1, right? And this is how we're going to graph our sine of theta and cosine of theta functions, because the sine of theta is going to correspond to the y value on the unit circle, and the cosine of theta is going to correspond to the x value on the unit circle. Right, and these are some of the most important properties to remember when doing any kind of trigonometry problem, is remembering things like that, that sine of theta is y value, cosine of theta corresponds to the x value on the unit circle. So let's draw the function sine of theta. So when we're looking for y values, right, and we display or represent angles in radians, so we're going to call this pi over 2 for 90, and pi is 180, and 3 pi over 2 is 270. That's going to be this line right here. That angle is 270, right? And then we're going to call this 2 pi for 360 when we make our way back around. And this is going to be, of course, 0, right? So sine of theta when theta is 0 is going to be the y value at this point, which is 0, right? So that's where sine of theta is going to start. Then at pi over 2, our y value becomes 1, because this point is 0, 1. Then it's going to become 0, and then it's going to become negative 1, and then go back to 0. So sine of theta is going to look something like this. And that's our sine curve, where this is negative 1 down here. This is positive 1 up here, and sine of theta is contained within the bounds negative 1 and 1. We sometimes call those boundaries where a function is contained as the bounds, right? So that's our sine of theta function. Now, if we're going to draw our cosine of theta function, we're looking for the x value at these different angle measures. So we'll label this axis again, 0 and pi over 2, pi, 3 pi over 2. This is going to be 2 pi, right? And then we're going to say, well, what's our x value when theta has these values? So when theta is 0, our x value is 1, so cosine of theta is going to start at 1, and we know that it's going to be contained within the bounds 1 and negative 1, so we'll just put negative 1 on the bottom on the y-axis there. And then so when theta is 0, cosine of theta gives us 1, right? Then when theta is pi over 2, our x value is 0, so cosine of theta has to be 0. And then we're going to come down here, and then if you look for pi, our x value is going to be negative 1, then it's going to come up for 3 pi over 2, our x value is going to be 0 again, and it's going to come back to 1 at 2 pi, right? So if we were going to extend our sine of theta and cosine of theta functions in the negative direction, which we can do because they do extend infinitely in that direction, and we called this negative pi over 2, and we called this negative pi over 2, well, cosine of theta would go to 0, sine of theta would go to -1. Right, so now if you can see here, if we could cut these functions, right, if we could cut the function sine of theta at this point and just move it over to the left by pi over 2, if we're going to call this distance is pi over 2, right? So we were going to pick this function up, chop it off right here, and move it over here. It would look exactly like the cosine of theta function. And what we call that in mathematics is when a function is out of phase. So the sine of theta is the function cosine of theta, but shifted to the right by pi over 2. Or we could write it as sine of theta is equal to the cosine of 90 minus theta. Or if we're writing in radians like we were using, sine of theta is the cosine of pi over 2 minus theta. Right? What this says is that the cosine function is the sine function, just shifted to the left by pi over 2 radians. And so what that means is that when you go to remember your special angles and you say, I don't know, I can't remember what the sine of 30 is, right? Or what the sine of pi over 6 is, right? 30 in radians. Well, the sine of pi over 6 or the sine of 30 is equal to the cosine of 60 because it's the cosine of 90 minus theta in here. So cosine of 60 equals sine of 30 equals 1/2, right? So you don't need to memorize all of them. You only need to remember one per function, and then you simply subtract the angle from 90 and it'll be the complement of that angle. And that's actually why cosine is called cosine. Sine is the sine of an angle, and cosine is the complementary sine. Right? And complementary angles are where two angles, angle 1 and angle 2, sum to 90. So that's where cosine gets its name from. It doesn't just come out of nowhere, and it's not just something that's made up. It's very much related to the sine of theta function. So that hopefully will help you to remember your special angle formulas a little more easily.